Hello, my name is Matt Marzillo. I am an AI cloud solution architect here at Azure. And in this video, what I'm going to be doing is showing an architecture and a brief demo of how you can leverage some healthcare data to quickly and efficiently, in a scalable manner, build predictive models, deploy them, and then leverage them using the Azure stack. So just to kind of level set, I'm hoping this only takes about 15, 20 minutes or so. I'm going to kind of run through a slide deck here, kind of showing off what the architecture looks like, what the use case looks like, and then also kind of show a little bit in terms of what the tools look like in Azure and kind of how you interact with them a little bit. So looking at the screen right now, what this is it's a readmissions use case, right? So we have a data set that, I'll kind of flip to the next slide here, that is basically, it's historical data. These are all diabetes patients. I pulled it from the website Kaggle. And each record in this data set is a patient that was discharged from the hospital, right? So it's historical data that we're going to use to build a predictive model on, right? So the target variable, the Y variable, is readmitted, right? Which is telling us whether or not a patient was readmitted back to the hospital within 30 days, right? This is an important metric that a lot of hospitals track, right? Readmissions are not a good thing. They're not good for the patient. They're not good for the hospital, for health reasons, for care reasons, for cost reasons, that sort of thing. The data set is 10,000 records. It has 25 fields. It contains numerical, categorical, and text features as well. So looking more specifically at the data, right, this is kind of what it looks like, right? So you can see here, you have numerical data like number of diagnoses, time in hospital, number of medications. You have categorical features like gender, race, primary diagnosis, the type of payer. You also have text features. So something like a diagnosis description, right? You kind of see it a little bit there on the right side. And there are tools within Azure machine learning that will allow you to kind of automatically parse through these features and kind of glean the pattern out between these predictor variables and that target variable readmitted. So the next slide, we're kind of going to look at a quick architecture. So this is kind of what it looks like, right, in terms of how you can stitch together this sort of solution. And a pattern like this, or a pattern just like this, is one that we see a lot. And if you're working with an architect at Azure, this is something that they've surely kind of helped their customers with. But in brief, we like to think of machine learning problems in sort of two phases, right? So you kind of have that top rectangle up there, and the first phase is how you're going to set things up to actually take your data and your historical data and build some sort of predictive model, get that machine learning model, and then deploy it somehow so that it can be leveraged in a production workflow, right? And that's the second phase down at the bottom, right? You have some sort of data engineering task, right? So let's say you're bringing data in from external sources using Azure Data Factory, copying that down to data lake and raw, and then you're leveraging some sort of transformation tool, something like Azure Synapse Analytics, to do the transformations to that data, join them together, and then also hit that managed endpoint that is the model to get inference back and write that down to some sort of serving layer. And in this case, it's that Synapse SQL pool, Synapse DW. And then from there, you can leverage something like a Power BI dashboard to materialize those inferences to your end users, right? So the idea being in this case is you can kind of take a look at the predictions and report those back to clinicians and say how likely each of these patients is to be readmitted. And then you can actually do something with that data, whether that's changing their discharge plan or reevaluating whether or not that they're going to be discharged, so on and so forth. So kind of a couple of things around, why we made these architectural decisions, right? So, we went with machine learning or Azure machine learning because it does contain a real wide set of tools, right? So it allows a lot of flexibility in terms of the skill set of the end user who's building the model, whether you want to use Python or R, or whether you want to use a user interface tool, or whether you have some pre-built models that you've already worked with and you just want to deploy them to Azure Machine Learning. Machine Learning offers that sort of robustness, and also scales really well too, right? So it has the concept of a workspace in Azure Machine Learning allows you to work with teams on projects in a scalable manner within organizations of small and very large sizes. Manage endpoints, the second thing there. So there's a number of ways to deploy machine learning models, right? Or just basically to leverage a model in a production setting, right? What we're seeing is that most of our customers are kind of going towards this managed endpoint because it's low overhead. It's really easy to go from model to deployment, and it allows a lot of flexibility to kind of how you use that endpoint, right? So once you have the endpoint, you can basically, technically speaking, you can basically use that from anywhere you'd like to. Obviously, there's sometimes security and other reasons for maybe why you can't access the endpoint. But once it's there, you can pass data into it to get predictions. And also with endpoints, you have kind of two flavors of it. There's the real-time endpoint where you have VMs that are spun up and running. It's an endpoint that you can send records or a record to quickly get predictions back. And we also have batch endpoints, which is VMs are spun up as needed. They're ephemeral, and it's more batch endpoints are more meant for volumes of data that are maybe done in a batch setting as opposed to real time, which is more kind of real time predictions that or inference that needs to be generated. You leverage Data Factory, which offers which is a kind of battle tested tool that we have for moving data and orchestrating different workflows. And then we have Synapse Analytics, right, which is I would say that probably the most used tool for data engineering in SQL. I'm sorry, in Azure, right? And it allows for you to write T-SQL or Spark to conquer those engineering tasks, and from there you can leverage the endpoint to generate inference. And then lastly, you have Synapse SQL Pools, right, which is the database component of Synapse, which can provide you your serving layer, and then you can kind of lay something like Power BI on top of it. So the slide before this, I kind of showed what the general architecture looks like, but I have a little bit of a more detailed architecture that kind of shows you how you might kind of look at it in a more detailed fashion. I'm not going to go over this in too much detail, but what you have here is basically a similar workflow, right, where you have this sort of kind of ML dev box up here where you're leveraging Azure Machine Learning to register models and deploy to an endpoint, right? And then you can also use a CI/CD tool like GitHub or like Azure DevOps to push the model to an endpoint. And then kind of the similar workflow here where you have the kind of production workflow where it's leveraging Data Factory to raw, using Synapse to generate curated data that's probably accessing this endpoint and then dropping it into Synapse SQL Pool. And then down here at the bottom, if you have some kind of real-time workloads, you can leverage something like Event Hub, Stream Analytics, and Cosmos DB. So there is a lot of flexibility around how you can kind of stitch together these different resources for your Azure Machine Learning workflow. So with that, I'm going to kind of get to a quick demo and just show you really quick what these tools look like in the wild and how you would leverage the machine learning or leverage these Azure resources in order to kind of build out this workflow, right? So I'm going to focus on Azure Machine Learning, Synapse, and then also Power BI. So really quick, right? So if you look in the portal here, just to remind you, Azure Machine Learning is it's a resource, it's a PaaS resource in Azure. Once you kind of spin it up, it takes a couple of minutes to spin up an Azure ML resource. And once it's here, you get this little beaker sign. You kind of click into it. You click Launch Studio, and it opens up a new browser with your workspace, right? And I'm not going to go through everything here, right? But what I like to kind of remind folks of is that in order to build these machine learning models, what you absolutely need is some sort of data, right? And you could create a data store here, right? So you can come here, you can click New Data Store, and you can mount a number of different storage types to access your data. And then from your data stores, you get your data sets, right? You click Create New Data Sets, grab them from your data store, or there's sort of easy button here if you wanted to if you're working on a POC, you can kind of just bring in a CSV file. So you need data and you need some sort of compute, right? You come down here to compute, and a workspace like this Azure Machine Learning workspace is often shared across, a team or across a group of people working on the same project. But you might have your own compute instance, right? And this is a compute instance just for an individual. And you can kind of open up a RStudio browser or a Jupyter browser. And you also have compute clusters, which is multiple VMs that are shared by all the users of the workspace. And they allow you to submit jobs to them, right? And you can kind of easily create these different types of compute depending on your access and the role that you have assigned to you. But like kind of coming back to instances, I'll just kind of show you really quick. You can kind of open up a Jupyter notebook, right? And it takes a couple of seconds here, but you can see here now you have a Jupyter notebook on your own VM that you're used to running. And if you want to, you can write Python and R scripts just like you're comfortable using if that's what you want to do. Additionally, once you have data and compute, you can come here and use these two additional tools, right? We have Designer, which allows you to develop a pipeline. I'll kind of just quickly kind of show you what this looks like to give you a feel, right? So you can kind of use these different, we'll call it widgets or tools to kind of build out a pipeline. So we can read in the data set. You can, maybe you want to sample the data set somehow, or, this is a sample data set. But let's say you wanted to take this data set and then train a machine learning model algorithm. You can, grab your boosted decision tree model right here. And actually, probably not a good one, right? Because that's regression. So let's get rid of that one because it's a classification problem. Let's say we want to. A lot of regression. Let's see here. Yeah, we'll do a classification here, classification logistic regression. And we're going to train that on our data set right here. And I'm not going to configure anything just yet. I'm just going to show you how this works. So you'll pipe the data into one set, and then you'll pipe the model into the other set. And you can see how you'll kind of start to build a pipeline. There's different sorts of transformations that you can include in here when you're building your pipeline out. And you can also kind of integrate, a custom R script or a custom Python script right here into your pipeline that you would then submit to a compute cluster. So that's the Designer, right? We also have automated ML, right? And with automated ML, what you can do is grab a data set, right? And let's say we have like this diabetes data set here. We'll click next. And you'll have to define several configurations, and you'll submit this auto ML run. And what it'll do is it will go out and grab many different machine learning algorithms. It'll do some feature engineering. It has some unique, rather sophisticated engineering algorithms to kind of parse out text data, and also some engineering on your categorical features, right? Do your one-hot encoding, and it'll do some transformations on your numerical columns. But all you have to do is, set up some sort of experiment, right? So you're kind of going to organize all of your machine learning runs into some sort of experiments. We'll call this, test diabetes. Define your target variable, right? What you're trying to predict. In this case, it's readmitted. And then you're going to have to submit that to some sort of compute cluster. You click next. And then define, is it a classification, a regression, or a time series problem? In this case, it's classification. And you have a couple of different feature settings. You have your featurization settings, right? So you can determine which features or particular variables you want to include in the model and whether or not you want to impute missing variables and things like that, and kind of quickly show what that looks like here. We'll leave that as is. And then you have these additional configuration settings, right? So what metric do you want to optimize this run on, right? Let's use something like AUC weighted, how you want to set up your validation, right? So AutoML is obviously going to split the data up. So you're evaluating the model on some of the data and training the model on other portions of the data. You can use something like K-fold, five-fold cross-validation, which is a common way to split the data. And you also have different methods around concurrency in terms of like how many nodes you want to run this on, and then exit criteria in terms of how long you're willing to let this run, right? And once you have all that configured, you can click finish, and now AutoML does its thing, right? So while this is kind of kicking off, and this one takes like 30, 40 minutes or so to run, it's worth mentioning that AutoML and Designer, right, can both be controlled from this UI, right, which is great, and that we have a lot of customers doing that. But it can also be controlled programmatically from our Python SDK. So you can make all those different configurations in AutoML with Python. You can also set up your kind of pipelines here, like we did here with Python as well. But once you're done with a run, you'll wind up kind of coming back to this experiment, right? And if I kind of come here to an old experiment with several runs, I can kind of come here to an AutoML run and look at the model leaderboard, right? And these are all the different models that were tested out, right? Optimizing AUC, which is, if you're not familiar, it's a measure between 0 and 1. Closer to 1 is typically better, right? Or not typically, it is better, or more accurate model. You can kind of see all the models that were tested out with different types of transformations. And then it also tries out some different ensembling techniques, right? So averaging together multiple models, using certain heuristics that we have to get a little bit more accuracy. And these tend to be the best models, right? You can see here the AUC is a bit higher than the rest. So if you click into that model, you can then look at several different things, right? You can look at, particularly look at different metrics, right? Oftentimes, you're not just going to look at one number and say, yep, AUC is 704, I'm good to go. You're going to want to look at something maybe like a confusion matrix, right? And I can kind of scroll down here and show you, on out of sample data, what do true positives versus true negatives versus false positives and false negatives look like, right? This is particularly useful in healthcare, right? Because a lot of times a false negative is much worse than a false positive, and looking at this type of data is going to help inform you as to whether or not you want to actually take this model to deployment, right? And you can see there's different information here. You have all your logs, different artifacts. Explanations is something that's getting built out too in terms of looking at different variables that matter and things like that. But ultimately, you want to deploy this model somehow, right? And right now, the best way to do that would be to you download the artifacts, right? When you click download, what happens is you download the 3 important files that come with a model, right? So you have your actual model, which is a binary file, a pickle file. You have your entry script, which is a scoring file. It's a .py that basically sets up the environment, and basically when you're creating the endpoint, it defines how it's going to receive the data and generate inference and set up the environment. You also have your environment file, right? So it's a YAML file that says what packages you're using and that sort of thing. So once you have those files downloaded, what you do, and I'll just kind of show you what it looks and feels like, is you would register the model, right? So you come here and you click register model, and you have to kind of define the name of the model. You would define the framework that you're using, right? AutoML, what version, and then upload that .pickle file right here, right? And this is how you would kind of set up that model and have it registered in Azure Machine Learning, right? And then once that's registered, what you'll do is set up an environment, right? So you would do the same thing, right? So we download that YAML file. So it's a matter of kind of coming here and saying, hey, let's upload the YAML file that we just downloaded. You can see what it looks like, right? It's maybe 27 lines of code, just defining the channels and the installs and things like that. And once you have that, it's time to deploy, right? And you would come back to the model that you registered, right? And you would say, hey, let's now deploy this, and you have the option to do a real-time endpoint or a batch endpoint, right? Let's say you want to do a real-time endpoint. You would just kind of test out, define a name to test demo, and then you would click next. You would verify that the model is correct. You have the ability to use multiple deployments. In this case, we're just going to have one deployment. Scoring timeout is 60 seconds. So let's say we're confident that 60 seconds is plenty of time to generate inference. We'll leave the tags alone. And then you come here and select an environment, right? So there's a pre-built curated environments that you can leverage, or you can leverage one of those custom environments that we already use, right? I'm sorry, that we already uploaded. And you would say like diabetes test, something like that, and then upload that scoring file that we just downloaded as well. Up there, you have to set up some sort of compute, right? So this is a real-time model, so it's going to be sitting on some sort of cluster. But let's say it's really kind of a lightweight real-time compute. It's, let's just say, these DS2 VMs that are only 14 cents an hour per core. Let's just leave it at 3. We'll click next. We only have one deployment, so 100% is going through it. We'll click next. And then you can review and then create your deployment. Now, it does take, maybe call it 15 minutes or so to deploy. And I'm going to cancel it out because I don't want to run it in the background. But once that's done, you would then come down here to endpoint, and you can view all of your deployments, right? So if I come here, this is one that I downloaded some time ago. Yep, and it was successfully provisioned, right? You want to make sure that it's successfully provisioned. You have the ability to test it right here by just kind of like inputting some values or uploading a CSV file to make sure that it's generating predictions the way you expect it to. And it looks like, based on those values, this person would be not likely to be readmitted. Then you also have this useful feature where you can kind of just come here, grab that endpoint URL, and take that wherever you want to take it for production, right? Or you can kind of come here and we have these nice kind of easy scripts for C#, Python, or R of kind of showing you how to set up your production code, right? And that's kind of a nice segue to be like, okay, once you have your production code, how do you set that up, right? So you can kind of come here and look at, this is an inference script that I have. It kind of shows you, how you might read some data, from Azure Data Lake, right? So say you have a data factory script that drops this data into Data Lake, and then the data factory then kind of kicks off this Synapse Spark run that then reads in that data, kind of selects the important features, and then passes those features onto our URL here to generate inference, and then takes that inference and writes it down to a Spark table, a Spark pool table, right? So if I come up here, you can see it's a quick query on that 10K table that I showed, right? And you can see here, this is basically showing us, say this runs every morning or every new shift, right? Looking at who's going to get discharged at a given shift, and shows us which folks are most likely to be readmitted, true or false here in this predictions column, right? And then once you have that data sitting in the SQL pool, you can then create a dashboard on top of it, right? So on a high level, you can see here looking at the average predictions by gender or by race, if you want to see if there's some bias in the model. Looking at it by payer code, looks like our commercial patients or Medicaid or Medicare patients more likely to be readmitted, as well as length of stay in the hospital, time in hospital, which is useful information to have. But ultimately, looking at something like this, like a floor plan chart of it, might be more useful, right? You can kind of hover over the different hospital rooms. I can kind of zoom in here a little bit and say, okay, which patients how likely is each patient to be readmitted, and what is a key subcategory or a key indicator that's driving that prediction, right? So it looks like this patient who's in room 6 has a 70% chance of being readmitted, and it's because they have a high number of medications, right? You can kind of scroll over. This patient has only call it a 10% chance of being readmitted. In room 5, maybe we don't need to kind of do anything there. And I kind of keep moving on and on here. I think there's a useful one here. Bear with me here. Yeah, okay, you can see this patient in room 1 has a 67% chance of being readmitted. And it looks like a key feature is their discharge plan says discharged home, right? This is actually actionable, right? So now it's like, okay, maybe if we change their discharge plan, we said, okay, let's say they're going to go to a skilled nursing facility or to another hospital or home with help, we could reduce that risk of readmission and start to actually gain some benefit from the model that we built and deployed. So yeah, so that's it, right? In quick, I think this is about 20 minutes or so. We've kind of showed you how to go from data to model to deployment to actual production workflow using all these Azure ML tools. So I know there's a lot here, and there's definitely some detail and some nuance in terms of if you actually want to stand this up on your own. If you are looking to stand this up, please reach out to your specialist, your account team, or your AI architect. This is the kind of thing we have a lot of experience doing, and we have many repetitions, and we're more than happy to kind of walk you through your first POC. All right, thanks a lot.